Nuclear bombs are among the most destructive weapons ever created by humanity. Their impact goes far beyond conventional weapons, causing devastating destruction through a combination of blast waves, extreme heat, and radiation. Nuclear bombs release energy through nuclear reactions, either fission, splitting atoms, or fusion, joining atoms. These reactions unleash an enormous amount of energy in a fraction of a second. There are two primary types of nuclear bombs: atomic bombs, fission bombs, which use the splitting of heavy atomic nuclei like uranium-235 or plutonium-239, and hydrogen bombs, fusion bombs, which are more powerful than atomic bombs and use fusion reactions to enhance the energy output. The sheer energy released by these reactions is what makes nuclear bombs devastating. When a nuclear bomb is detonated, its destructive power unfolds in several stages. Within microseconds of detonation, the bomb creates a fireball of extreme heat and light. The temperature at the center can reach tens of millions of degrees Celsius, hotter than the sun's core. The fireball expands rapidly, vaporizing everything in its immediate vicinity: buildings, vehicles, trees, and living beings. The explosion generates a shockwave or blast wave that moves outward at supersonic speeds. The initial blast pressure flattens buildings, shatters glass, and causes widespread destruction. Structures close to ground zero, the point directly below the explosion, are completely obliterated. The radius of the blast wave depends on the bomb's yield. A 1 kiloton bomb may destroy structures within a radius of 0.5 kilometers, while a 1 megaton bomb can cause destruction up to 10 kilometers away. The explosion emits intense thermal radiation, releasing visible, infrared, and ultraviolet light. This radiation causes severe burns on exposed skin and can ignite fires over a wide area. Even people miles away from the explosion can suffer third-degree burns if they're in direct line of sight of the fireball. Nuclear bombs release large amounts of ionizing radiation, including gamma rays and neutrons. People close to the explosion are exposed to lethal doses of radiation, causing immediate sickness or death. The bomb also generates radioactive fallout, where particles of earth and debris are irradiated and carried into the atmosphere. Fallout spreads over a wide area, contaminating soil, water, and air. Exposure can lead to long-term health issues like cancer, genetic mutations, and environmental damage. A nuclear detonation produces a powerful electromagnetic pulse, especially at high altitudes, which disrupts electronic devices, power grids, and communication systems over vast distances, causing technological chaos. The effects of a nuclear bomb are categorized into different zones based on distance from ground zero. In the total destruction zone, within a radius of 0 to 1 kilometer, everything is vaporized, leaving no trace of life or structures. Even reinforced buildings and underground bunkers are destroyed. In the severe damage zone, within a radius of 1 to 3 kilometers, most buildings collapse and fires break out. Survival chances are minimal due to the combination of blast, heat, and radiation. In the moderate damage zone, within a radius of 3 to 10 kilometers, structures suffer significant damage but may not be completely destroyed. Survivors may face severe burns and radiation sickness. In the fallout zone beyond 10 kilometers, radioactive particles settle over a vast area, depending on wind patterns, contaminating regions hundreds of kilometers away and making them uninhabitable. The immediate effects of a nuclear bomb include incineration of forests and vegetation near the blast, while fires started by the thermal radiation can merge into firestorms, consuming everything in their path. Long-term effects include radiation contaminating the soil, water, and atmosphere, affecting agriculture and ecosystems. Fallout can cause mutations in plants and animals, disrupting food chains, and entire regions may remain uninhabitable for decades. A large-scale nuclear exchange could eject massive amounts of soot and ash into the atmosphere, blocking sunlight and lowering global temperatures, a phenomenon called nuclear winter. Crops would fail, leading to widespread famine and ecosystem collapse. Immediate casualties include people near the blast, suffering instant death due to vaporization or crushing injuries, while others face severe burns, blindness, and radiation sickness. Long-term health effects for survivors, known as hibakusha in Hiroshima and Nagasaki, often include cancers, infertility, and birth defects. Psychological trauma, known as nuclear PTSD, is common among survivors and their descendants. Economic and social collapse can occur, with entire cities wiped out, leading to mass displacement and economic ruin. The loss of infrastructure disrupts food, water, and medical supplies, worsening the humanitarian crisis. Historical examples include the U.S. dropping atomic bombs on Hiroshima and Nagasaki in 1945, killing over 200,000 people and causing long-term radiation effects. Hundreds of nuclear tests during the Cold War caused environmental and health issues in test regions like Bikini Atoll and Nevada. Efforts to prevent and mitigate nuclear destruction include disarmament treaties like the Non-Proliferation Treaty, civil defense measures such as shelters and evacuation plans, and decontamination efforts, though these can be expensive and challenging. A nuclear bomb doesn't just destroy buildings and lives, it devastates ecosystems, economies, and the human spirit. Its effects are far-reaching, lingering for decades, and serving as a grim reminder of humanity's destructive potential. The only real safeguard against such devastation is global cooperation to prevent their use entirely.